Welcome to another video. In my previous video, I said I was trying to solve a problem and my research led me to Kummer's theorem. Now, Kummer's theorem is very relevant to this problem. In fact, that's all you need and just basic common sense to be able to answer this question, which says we should compute the smallest possible integer k such that 49 divides 2k choose k. Okay, this expression is 2k combination k. Now, as long as you can write 49 as the power of a prime number, you should be able to figure out what the answer to this question is. And remember, we're looking for the smallest positive integer k. Let's get into the video. So what I would do first is state Kummer's theorem, which is the whole idea of this problem, and then rewrite this problem to fit the theorem, and then we're going to do the work using just basic algebra and common sense. Okay, so let's state the theorem. The theorem says, this is Kummer's theorem. I'm going to state it the way I like to state it. Let P be prime and P to the M be a factor of n choose k. So we're saying P to the M divides n choose k, where m is an integer, okay? Now, we say m, then m is equal to the number of borrows. Let's do borrows first. The number of borrows of n in base 7 minus k in base 7, or the number of carries in n minus k base 7 plus k base 7. So there are two ways that you see this. If you choose to write this in base 7, you write this in base 7, and you decide to subtract the smaller from the bigger. The number of times you have to borrow from this side to be able to do the subtraction, if you count the total number of times you borrowed, that's going to be the value of m. Or if it's going to be the maximum value of m, actually, I should say the maximum value of m, well, which is still true, okay? Now, or if you decide to not do subtraction, if you decide to do addition, which is what I would do, is you first subtract k from n, you get another number, and you write that number in base 7, you add it to k in base 7, whatever you get, the number of times you carry over numbers will become your m, the value of m. I hope I stated that exactly right. So what we're going to do is look at the problem that we have and decide what our p is, what m is. We know our n, and we already have our k has not changed. So let's apply it to this problem. We have our n equals 2k, so that n minus k equals 2k minus k, which is equal to k. So the two parts of what I just wrote here would be k and k. Okay, so that's the first thing you want to take care of. Also, what is our p? Well, what prime number is 49 a power of? 49 is a power of 7, so it's 7 squared. So we also know that P equals 7, which means that 49 can be written as 7 squared. So clearly we have found our M already. Remember, they're not asking us to find M, they want us to find K. So, which implies that M is equal to 2. So we found most of the ingredients we need for this computation. The only thing we don't know what K is, and we don't know what 2K is. But once we find K, we'll be able to find 2K. So, like I did in the previous video, I would rather do addition than do subtraction. So what I'm going to say is, so this means that M equals 2 is the number of carries when n minus k written in base 7, n minus k written in base 7 is added to k written in base 7. Remember, that's the definition. The difference between the two numbers written in base 7 added to the lower number, the number of carries. We have already seen that is, what was our n minus k? It was k. So when you write k in base 7, k in base 7 plus k in base 7, you will have 2 carries. Now, in order to have 2 carries, you must have more than 2 digits, because if you have to carry 2 times, it means there has to be a 3rd digit or a 4th digit or a 5th digit. But the question says compute the smallest positive integer k. So we're going to go as small as possible and say the number we're looking for has 3 digits. If we don't get an answer, then we can move to 4 digits. But because we're looking for the smallest positive integer k, we have to stick to 3 digits. Okay? To get 2 carries, we must have at least 3 digits in this number, in k base 7 plus k base 7. Remember, k plus base 7 plus k base 7 is going to be 2k in base 7, because that's what this was. This was 2k, because 2k minus k is k. Okay, in 2k. Okay, in 2k base 7. Another thing that makes this problem easy is that the two numbers we're trying to add together are the same. So you have to start imagining, if I have to have a carry on the first digit, so watch what happens. If let's say k to the 7 plus k to the 7 will end up becoming, let's say, a, b base 7 added to a, b base 7. Notice that when I add these two numbers together, they must be equal to or greater than 7. But the smallest number that b can be has to be 4. It cannot be 3, because 3 plus 3 is 6. You will not experience a carry. So b has got to be 4. So we're going to say this has got to be 4. Let's say it is a. We got 4. We got a. We got 4 base 7. These are the 2 digits. When you add 4 to 4, you're going to have the number 8. But 8 is 1. You write 1 here, you carry over 1. Remember? Because there are 1 7s in 8. So you take this 1, you add it here. When you get here, there must be another carry. The only way there will be a carry is that after you've added these two together, you still add the 1 to it, and it's now more than or equal to 7. So the smallest value you can get here is 7. So this has got to be 3, 3, and then you get a 0, and then you get a 1. So we can say that for this to be correct, this has got to be 3, and this has got to be 3. So this has got to be 3. This has got to be 3. This has got to be 4. Or B has got to be 4. So we can say, since K is the smallest, AB base 7 must be 3, 4 base 7. Because that's the only case in which you'll be able to pick out 2 carries. Remember, we need 2 carries, right? Okay, and that's basically what it is. Sorry, I'm bothered by the sound that I'm hearing outside. And I don't know if the mic is picking up those sounds or not, but they're the sounds of children, so forgive me. Forgive them also, for they don't know what they're doing. So, and that's basically what this is going to be. So what is 3, 4 base 7? Because that's the value of K. So therefore, K equals 3, 4 base 7, which is 3 times 7 to the first plus 4 times 7 to the 0. That's how you convert a number from another base back to the decimal system, which is base 10. So what is 3 times 7? 21. What is 4 times 7 to the 0? Is 4. So K is equal to 25. And this is the answer to this problem using Kummer's theorem. Never stop learning. Those who stop learning, stop living. Bye-bye.